behind, but anyway. So all I did, we did some extrapolations today. Just want to bore people again that they have to see this again. Threw a fit to get a good. Okay, the idea of an oblique Cavalieri's principle, and the idea that an oblique prism or cone or whatever, the volumes would be the same. Okay, so I'm just going to go over that real quick and just do the brass tacks of it. So the volume of this prism over here is still length times width times this height, straight up and down. It would work. But the lateral areas are different in oblique prisms, and we will not ask you that. It would take more complicated stuff to find the lateral area. You'd have to break down each. You'd have to really think about the net and get each part of the net taken care of for that. No specific formula, I believe. So then we went to this. Okay, so there's an oblique prism. It's not right because none of those are right angles. That really looks slanted. It almost looks like it's going to fall down, right? These squares don't look parallel. I might have done that. I might have distorted the image. Who knows? But what's missing here is the actual height. So I did want to cover this one and remind you about, I guess, radicals. So I need big B times H. I need that H. You need the straight up and down height. The height is not 17 in an oblique situation. So what theorem is that? 3, 2, 1, go. Starts with P. Pythagorean theorem. And it'd be H squared plus 3 squared, get your parts in the right spot, equals 17 squared. If you still don't know the Pythagorean theorem, you're doomed. And that's not me. That's nobody else. This is what I talk about, some people so far behind because of the lack of homework doing on a daily basis. Never, ever works in this class. 17 squared, that's fine. 17 squared is actually from last hour. I guessed 259 first. Very bad guess. And then I found out it was 289. So 17 squared is 289. 3 squared is 9. Subtract, and you get 280. Another formula coming up here in the next chapter is the quadratic formula. You want to sing? Remember that? B plus. Well, you'll be back. This will take care of your tardy that I was going to mark you for. Go ahead. The opposite of B. Wait, you want me to? Yeah, the whole thing. They can't hear you. So I'll do it to you. Let's do it again. The opposite of B plus or minus the square root of B squared minus 4AC all over 2A, which has nothing to do with this. I'm sorry. But we just wanted to do that. Next chapter. And then do you remember this? What's 280? A number. What times what equals 280 super fast? 28 and what? 28 and 10. So this is, remember how we simplify radicals. I get people in tutoring and they keep going, they keep treating, they keep getting the individual numbers, all the way down to prime factors. No, I disagree. What's 28? What times what? 4 times 7. And then what's 10? 5 and 2. And I'm going to stop there. Do any of these end up being perfect squares or make up perfect squares? Yes or no? No. But if that was, say that was 28 and 20 or something like that, then this is 4, and then 4 times 4 is 16. We brought it back to 16 because everyone can tell me what's the square root of 16. 3, 2, 1, go. Unless you're innumerate, which is part of the problem. So my seniors cannot do that. Square root of 4 is 2. And then those don't create perfect squares, so I got to multiply them back. 2 times 5 is 10. 10 times 7 is 70. And then that's easy for volume. It's big B, which is just 5 times 5, now times the height, 2 root 70. That's 25 times 2, which is 50 root 70. Probably got the shakes. Root 70 seems like 70 should be able to break out, but it doesn't. 10 times 7 and 2 times 5, nothing breaks out. There's the exact. We love exact on the test, so hopefully you're ready for that. That's an oblique cylinder. Please, it's big B times H with Cavalieri's principle. So it is, what is big B though? It's a circle. So it's 6 squared pi times that actual height, 15. I could have done something else, like give you the slant height, and then you got to use some sort of Pythagorean identity or something. I don't know. All right, 36. I think I did this 360, and then half of 360 is 184. So 540. I remember that. 540 pi. And then I didn't do units on this one. I did do units on this one, so this is inches cubed. Better watch it. I sent some people back to their desk without units. Sorry for pointing at you. Better watch you on the test because it's either inches cubed or inches squared, depending on the question. If you don't write it, you make me take a half point off. So this should be units cubed. All right, and then this one is just to remind you of 1/3 big B times H. All right, and then that is 1/3. Big B is again a square. Probably could have done some better ones like area of a trapezoid. So a trapezoidal, pyramid, although the rectangles wouldn't be equal, so you got to be careful on that. That one you have to draw net. I think that's where we got people making some things wrong. In a trapezoidal prism, the rectangles are not all equal. You actually have to think about the net. Okay, but anyway, times 15, and then you can calculate. All right, I'm done blabbering. If you didn't watch the video, you again created your own problems, but what is this the volume of? 4/3 pi r cubed, a sphere. And then the actual surface area of a sphere, if I remember correctly, is 4 pi r squared. There must be some sort of deriving between those two. I don't know what it is, but I've never looked into deriving that formula where that comes from. So that's the actual how much leather you would need to make the basketball if you think of a ball. And then that's how much air is inside the basketball. The space inside that holds. Okay, and then there's a little worksheet for that, and I'll throw that online for those that are not here. Okay, super fast day.